All right, so welcome to geology one last time in tectonics. Let's do one last tectonics video. Call it good. Wegener, that's how you say that guy's name, had this idea based on the idea that one, hey, it kind of looks like those continents fit together. Okay, cool. Two, and this one's kind of more critical, there were matching fossils, ancient fossils, that existed in this part of South America, this part of Africa. This happened in a couple different places, right? Now, this would have been a time where they thought that the continents, they being humans, thought that the continents were just kind of where they were, and that was it. They had to come up with some ways to describe how the mountains formed and things like that. But there was the idea that North America's here, Europe is here, Africa's here. How are you going to tell me that the whole continent's moving? It was kind of logical to say that this is just how they are. But Wegener's saying, you know what, maybe not, because yeah, they look like they fit together. But also, I'm seeing matching fossils on either side. So what's the deal? Did this animal live in this very narrow band and then manage to swim all the way across the Atlantic Ocean and live in this very narrow band in Africa? If it was that good at swimming, it probably would have made it into a wider geographical area, you know? That's not likely. What is likely is that these continents would have been mushed together. That narrow band existed at one place on Earth, and that's that. Same for all of these. There's a thing called glacial striations, which we'll learn about when we get to glaciers, where scratches in bedrock, as heavy glaciers roll over the bedrock with other rocks embedded in the bottom of the ice, they leave scratches. Those found also match the pattern, and this is from an ancient glaciation. This is not from the Pleistocene, recent one that affected upstate New York. But those match only if these continents are kind of pushed together like this too. So there's building evidence that Wegener is trying to popularize to say that, hey, at one point all these continents were together, and he named it Pangea, all land. And it was kind of like, this is kind of a lesson or an idea in how science works, right? It was kind of like, okay, that's cool, man. There's some good arguments there. I buy it. But how are you going to tell me that South America is just like rolling across the planet's surface? Like, how does that work? And Wegener did not have very convincing arguments for this thing. He called it continental drift, but didn't really get bought into big time. All right, it was difficult for people to try to explain, which makes sense. Again, I'm sitting here on the North American plate. I don't how are you going to tell me that North America is moving, right? So the mechanism just wasn't there for his Pangea theory, for his continental drift. So what eventually happened, now in your textbook here, this is following the book as per usual, it does talk about hey, here's these other, I'm not going to ask you about these straight up. The stuff on page 4, so people said okay, maybe here's how mountain ranges formed. It's kind of neat, but I'm not going to include it because it's not stuff that's accurate. Let's just go right from Wegener to how did we actually figure this out? Once we got here, and this is real, and unfortunately Wegener died first, but once we got to figuring out how to test the depth of water and then go and make accurate maps of the ocean floor, we started finding some cool things. It says here, and this, this would be outrageous to do. Ocean depths were measured using weighted lines dropped overboard. Insane. You couldn't do that in the harbor outside of Oswego in any sort of efficient time, let alone an ocean. So we really did not have a good image or view or idea at all of what the bottom of the Atlantic Ocean looked like or any of the other ones. Then once we started doing these scans, all this, and you could cover a lot of space efficiently, all of a sudden it turned out that there's all kinds of interesting stuff going on down there. So this is a good place to wrap up tectonics, because now we can say, hey, we've covered all these in pretty good detail. We know what's going on. We've figured out mid-ocean ridges and talked about the mechanisms behind that. Now, this is how it was discovered. Those scans of the ocean floor, all of a sudden we saw this ridge and said, what's going on there? We saw more detailed images of continental shelves. We saw this deep trench over here on the coast of South America, and not only Hawaii, but that whole Emperor Seamount that comes off of it. And all of a sudden, people had to start throwing together ideas, go back to what Wegener said and said, oh yeah, you know what? Hey, maybe that guy was right. At this ridge, if we have spreading going on with brand new crust being formed in the middle and this pushing out, that offers a mechanism for Wegener's continental drift idea. That's how we formulated plate tectonic theory, how we've put together this theory to encompass all of it. And then everything comes off that easy. All of the earthquakes that happen, again, trace those boundaries. We have explanations for why the Himalayas are here, because India's in a car wreck with Asia. We have a mechanism for the Andes because this plate is subducting underneath. We have a mechanism for the Aleutian Islands over there because this plate is subducting underneath. We can talk about the hotspot in Hawaii and the trail of islands that come off of that because the plate is moving over a hotspot. It all came together fairly quickly once we could get a good view of the ocean floor. And that is what gave us plate tectonic theory. Is there anything else we want to mention here? And then I think one thing that popped here that's kind of interesting that I don't think I mentioned this when we did these divergent boundaries, is that the sediment thickens with the older crust. We did say, hey, the crust gets older and older and older as you go away, but the sediment also gets thicker. Why would that be? Well, if that crust has been there for a while with sediment settling down off the continents from the oceans, the longer it's been there, the more time it has to accumulate that sediment, the thicker it will get as it goes. All right, that is it. That's tectonics. Thank you very much for all your work, and we'll see you at the segment quiz and get ready for the next unit, rocks and minerals. Take care, everybody.